Hi there. My name's Tanner, and we're trying to figure out what the moon would be like if it were made entirely of Swiss cheese. But to do that, we're going to need to go shopping. So even though money doesn't grow on cheese, we're going to need to spend some cheddar. It may be Swissful thinking, but I believe I know just the place. So be a good sport and tag along. Just got back from the supermarket with this block of Swiss cheese, and so the next step will be to figure out the dimensions of the block as well as how many holes are on its surface. Next, let's find the mass of the cheese block. Now that we've found all of our measurements, it's time to find the surface area and the volume of the cheese block, which we'll use to determine the hole and mass densities of it. On the board, I wrote down the length, width, and thickness that we measured of the cheese block and then converted the meters. So to find the surface area, it's simply the area of each side summed up, which means it's 2 times the length times the width plus 2 times the width times the thickness plus 2 times the length times the thickness. That comes out to 0.026 meters squared. And then to solve for the volume of the cheese block, since it's a rectangular prism, that's simply length times width times thickness. And so that comes out to 0.0002 meters cubed. Now we can determine the hole and mass densities of the cheese block, and we'll start with the hole density. That's simply the number of holes per unit area. Assuming a uniform hole density, that's going to be equal to the total number of holes divided by the surface area of the block. When we solve for that, that comes out to 7,077 holes per square meter. And now we can do the same thing for the number of big holes, which we defined as holes greater than 1/8 of an inch on the cheese block. When we calculate that, that comes out to roughly 846 holes per square meter. This means that roughly 1 in 10 holes could be classified as big holes. Next, we'll calculate the mass density of the cheese block, which is the mass per unit volume. That's assuming a constant mass density is going to be equal to the total mass divided by the volume of the block, which when we calculate that will be equal to 1,110 kilograms per cubic meter. Now we can find the number of holes on the surface of the moon, assuming it's made out of Swiss cheese. As we already discussed, a uniform hole density is equal to the total number of holes divided by the surface area. We can flip this relation around to figure out the number of holes on the surface of a cheese moon. But first we'll have to solve for the moon's surface area. Assuming the moon is perfectly spherical, and knowing its radius is 1,740 kilometers, the total surface area comes out to 3.8 times 10 to the 13th square meters. Now, to solve for the total number of holes on the moon, it's simply the hole density times the surface area, which that comes out to be roughly 3 times 10 to the 17th. We can follow that same logic to solve for the number of big holes on the moon. And that value comes out to roughly 3 times 10 to the 16th. Next, we can solve for the total mass of the cheese moon. As we discussed earlier, a uniform mass density is equal to the total mass divided by the volume, and so we'll need to determine the volume of the moon. Once again, assuming the moon's perfectly spherical and knowing its radius is 1,740 kilometers, volume is equal to 4/3 pi r cubed, which comes out to roughly 2.2 times 10 to the 19th cubic meters. Now that we know the volume, we can solve for the total mass by multiplying mass density by volume. And so the total mass of our moon comes out to roughly 2.4 times 10 to the 22nd kilograms, which is roughly 0.4% the mass of the Earth. So to sum things up, these are the calculated values that we found, and these are the values associated with the actual moon, which says that there are roughly 500 million craters that are greater than 10 meters wide, and the mass of the moon is around 7.3 times 10 to the 22 kilograms, which is roughly 1.2% the mass of the Earth. Thus, a moon made entirely out of Swiss cheese would weigh roughly 1/3 of the actual moon and have inconceivably more holes, acknowledging, of course, the holes that we measured on our block of Swiss cheese are much smaller than the 10-meter holes observed on the actual moon. If you enjoyed watching this video, please feel free to leave a like and subscribe for more fun, science-based content. Thanks for watching.